Alright, hey, what's up everybody? This is episode 8 in our ASM journey or video series on how to go from noob to veteran ASM coder. Last time, in the previous episode, we did an entire video on the assembly tutorial thread. But before that, episode 6, we were doing it essentially the first half of this thread, how to make your own cheat codes. So now that you've read over the first half of this thread and you've done the entire assembly tutorial, it's time to go on to chapter 7 of this thread, making your first code, parentheses part 1. So let's get started. So for this guide, we're going to try to make a code that will change our online position, or essentially allow it to set it to a value that we want. So what we're going to do for this example is we're going to pretend we have a friend who can help us make this code, because we want to make this for online use. So a little quick tip is that if you want to make a code designated for online use, make it when you're online. If the code, what you want to make is for offline purposes, make it offline. I know that kind of sounds like plain Jane common sense, but you'll run into a few situations. Well, sometimes a person may forget that and whatnot. So key little tip. And then one thing I forgot to mention, I should have mentioned in episode 6, but if some things, like some panels, like the code view, you can only view it when the emulation is paused. So if we pause the emulation, it'll tell us what instruction we're about to execute. Okay? Unpause the emulation, code view you can't see. The registers, now you can see all the time, but they only get updated every time you pause. Unpause, pause. Unpause, pause. Alright, so just a little tip right there. Okay, so let's get to making this position modifier code. Make sure you have all your panels open. Go ahead and open your WeRD ASM compiler. Obviously have your Dolphin memory engine up with the live RAM viewer itself running as well. So we have everything up and we're ready to go. So I'm going to go ahead and create a room. I'm going to have our so-called friend join. Okay, so a very important tip I want to stress when making codes online is that you want to use a code made by Bully called No Disconnect. Obviously, we have it on the forum. It will be under the subcategory online non-item. Obviously, for both our simulated friend and myself here on Dolphin, we're both running the no disconnect code, so that way we can just remain idle forever in this room and not disconnect unless we actually have a real internet disconnection. Okay, so let's get started. We'll just use just normal versus race, because the code we're making has nothing to do with battle. It has nothing to do with teams or anything like that. Obviously, for a code like this, it doesn't matter what character or cart or track we are using. The only thing we need to be concerned about is our position. Okay, so some quick tips. Obviously, if you pause the emulation on Dolphin, it will cause you to DC in the race. You can get away with keeping it paused for a few seconds and unpausing, especially if there's a good connection between the two people or between all the people in the room. Just remember that. So let's get started. So we're going to be using Dolphin memory engine because it updates memory live, and we can do all types of search results, string results, and whatnot. When you're coding, you're going to make a little bit of guesswork, some assumptions if you're working on a brand new code or some type of thing that's never been really discovered or worked on before. So let's pretend this is the case. So let's assume the game uses the byte value 1 for position first place. And we're going to assume it's like byte value 2 for second, etc., etc. Keep in mind that obviously we're working with hexadecimal. So when we get to 10th place, if we were running a thing for 10th place, we would use the hexadecimal A. We wouldn't use 10. However, with Audelaro's program, you can use decimal and convert it for you. It doesn't matter. We'll just stick for decimal because we're just using 1s and 2s. We'll leave this menu here for byte, and we're searching for exact values. So you're going to click 1 right here, and then you go click first scan. We have a shit ton of results. So now what you need to do is we're going to try to shorten those results. We went to second place, change this value to 2, click next scan. And now we got less results. And you have to be pretty quick with this because you have 5 minutes in a race unless someone makes a code to disable that or whatnot. Now we're going to change it back to 1. We're back in first place. We're going to keep repeating this process. One more time. Next scan. And what we can do now is we're going to remain in first and keep clicking next scan until now we're left over with about 5 results. It seems like it's not going to get any more of a smaller list than this. Click the add all button. So obviously with coding there's going to be a little bit of guesswork. There's going to be times where the code will just fail, or you'll just fail along the way of making the code. These things are expected. This takes time. This takes a little bit of guesswork. So we have 5 dynamic memory address listings we got to go through. I can already tell you off the bat that the first one right here is not correct. Okay, it's the second one that works for this code. So let's assume you did this, you went through the first one, it failed, you had to redo this entire process. Go ahead, do the second one, browse memory at this address, right click, click this option. Now you go see right here at the top left. Look at this value in blue when I change my position. You see it update every time I change my position? Okay, so remember what I told you about breakpoints in episode 6? We're doing memory breakpoint. This is for dynamic memory, instructions for static. Now, we're going to set this action to break. Always use break for just the action. Now, condition, read or write. We want to figure out what instruction is writing this value, making this value possible. So we're going to select write. Now for here, you need to put this exact memory address in the listing. Be absolutely sure you entered this right. 80E8B454. Click it. And now the game pauses. Some things to note, and obviously this is going to DC the match. Sometimes or like a breakpoint won't break until that value in dynamic memory changes, like once it gets updated. For this code, this value in dynamic memory gets updated like every frame, if you will, all the time, essentially. So this is why this value, quote unquote, broke instantly. Now we did write breakpoint, but let's say you had a value and you wanted to know what read it, like you would use read breakpoint. So when you do write breakpoints, most of the time they'll break on some type of storing instruction. We see we have it highlighted in green right here. We have a store byte instruction. Obviously for read breakpoints, chances are it's going to be a loading instruction, because loading is for reading. Loading is for reading from memory. Storing is writing to memory. Okay, so first off the bat, once you get your breakpoint, you're going to go to your code view, because the emulation gets paused automatically, so now we can see the code view. So take a look at that instruction. Store the byte, register 7, to the effective address of register 3 plus the offset of 20. Okay. Now let's look at our registers. Let's check this out for a second. What's in register 7? Look, it's the value of 2. Our position value that we were currently at when we set the breakpoint. Now let's look at what's in register 3. Okay, we see this value. Obviously this designates a memory address in dynamic memory. In episode 2 I told you how certain high portions of mem80 can be dynamic memory. We'll check it out. We're in a high portion of mem80. This is dynamic memory. So if you take this value in R3 and you add 20 to it in hex, what do you get? You get our exact byte address right here where our position byte is located, the effective address. Okay, so now we know what register 7 is for. We know about our effective address in relationship to register 3 and how the register 3 value plus 20 to hex equals our breakpoint byte address for our write breakpoint. So now we can go ahead and actually make a code out of this. So our objective for this code is to be able to modify what our position is, be able to select what any value we want in our code, set it to whatever value we desire, run it online, and then have our position modified. So first things first, bring up your compiler. Now go to your code view, right click on the highlighted address, copy address, okay? Put it here, and notice how our breakpoint in code view goes to a static address. Remember in episode 2 I talked about that hierarchy, how the static memory controls the dynamic memory, okay? So we have our static address right here. I like to put capital letters and stuff just for sake of use. I'll change that really quick. Okay, so first things first, for 99% of ASM codes you always need the default instruction of the static memory address. This is our default instruction. Keep in mind when I'm typing, the code view might change because I have certain hotkeys and shortcuts to make the game step every instruction or to resume emulation, so I apologize in advance if this happens. But anyway, I'll just go ahead and screenshot it on my computer just in case, but if I lose it, which we won't because we're recording. But if you want, it's always a good idea if you found some default instructions but you don't want to really do anything with them, you want to maybe find another default instruction, keep a list. Obviously just screenshot them on your computer or whatnot, or just make a list of them. Okay, so we have our default instruction. Let's go ahead and type this in our compiler. As mentioned before, for 99% of ASM codes you need the default instruction of the address, or else the game is not going to function correctly. Once you get to writing complex ASM codes, and depending on what you want to do with the code, you will know whether or not you need the default instruction, or whether or not you are making code and you want to just modify the default instruction and include other things. So as mentioned before, we want this value to be modified to whatever we want. So for sake of demonstration, let's say we want this to be first place, right? Always. Because we know this code executes every frame. So when our cheat code gets executed, it will get applied every instant of the game when we're in a live race. Okay? So we need to modify this register 7 value, right? And obviously, because it's getting written in memory, we want to modify the value before it gets written in memory. Now, if we have like a loading instruction, we want to do it after the fact. But since we're working with a writing type instruction, writing the memory, we want to do everything before the fact. So this is pretty simple. We just want to set our register 7 to a value of 1 to represent first place. Let's put that in here. And if you followed the previous episode on the assembly tutorial, you know that generally speaking, instructions execute going from top to bottom. So the load immediate instruction will be executed first, then the store byte, our default instruction. And just for ease of view, if you're having problems viewing that, this is what we have. This is our default instruction that we have in the code view. We want to modify the value, our position value, before it gets written to memory. Alright, because the game already has something in register 7 by default, by how it does its own functions to figure this out before it writes to it. So what we're doing is we're modifying the value before the game stores it. Okay, so load immediate, register 7 1, our default instructions, store the byte, register 7, in reference to register 3. Okay, now, another thing to note, all ASM codes, their sources need an odd amount of instructions. As you can see, we have 2 instructions. So when this is the case, we usually just add a NOP. NOP basically just tells Broadway to wait 1 clock cycle to essentially do nothing. That's all it means. It's just wait 1 cycle. However, all ASM compilers have this NOP auto-configured if the amount of instructions you have in your source is even. So we don't even need this. It'll be done for us automatically once we compile. So we have our address, we have our source, we compile, and there we have our code. And it is a compilation error. Either WeRD was not set up correctly, you didn't set up the WeRD directory correctly in episode 6, or you typed something incorrect in your source, whether you have an invalid instruction or some type of invalid format. So let's go back to our big screen text editor, and this is the compiled code. Well, let's take a look at the compiled code, because even though technically, like I said, it's unreadable because it's in compiled hex byte code, we can still decipher a lot of it. Obviously, we know it's an ASM code because of C2. We know about our static memory address because of this. With this byte, we know how many lines of compiled code underneath we have in total. And look here. This is actually the compiled instruction of load immediate. If you see the 1, notice this 1 there, and notice this 1 here. Simple enough. And our default instruction, the store byte, is this compiled word right here. Remember, I told you every ASM compiler auto adds a NOP if needed. There's our NOP. And this right here, I explained, I think in episode 2, this is required for all ASM codes that use the Gecko code handler. It needs a final word of zeros. And this is all done for you automatically. You don't have to worry about it. So, let's say we want to do 3 for our position, or 5. We want to make this modifiable, or allowed to be modified by the end user if we were going to post this on some website or post it on mkwe.com. Well, we know we have a range of 1 to 12, which is here. Alright? Or excuse me, not 0 to 12, 1 to 12, pardon me. 1 to 12, or 1 through C in hex. Remember I said all byte code is hexadecimal. So what you can do is you can put like an X placeholder here for this code, and you could put X equals position hex. And the user can fill out anything from 1 through C. Like that. So, or you just leave it like that. So there we go. Now, I've made this is one of the first ASM codes I ever made. I can tell you off the bat that this already works. If you set this to like 1, for example, and let's say I had my simulated friend hop back in, and we were changing positions, my position would stay in first place. And on my side, it would show I'd win the race every time. So there's a little FYI on that. Some things to note. There are multiple different ways to make codes. The possibilities are endless. One thing I want to stress is do not have a copy paste mentality. A lot of newbie coders have this thing where they'll learn some stuff, doesn't matter what it is, they'll just plug it in and use this. I'll just try this random value here, like the people who just NOP random addresses on a hex editor. They just do the same process over and over again, but in different memory addresses essentially, just hoping randomly something might work, but they have no idea what they're doing. Like I said before, there will be some guesswork in ASM, but generally speaking, you have a goal, you know what you need to do. Once you get the info you need from the registers in the code view and Dolphin Memory Engine, you know what to do with that information, and you can accomplish making your code, or at least get very close. So every situation you have for making code is going to be different. Don't just do this method I did right here and try to make 100 codes out of it. I'm going to just change a byte value back and forth, back and forth, back and forth. The possibilities are endless. How to search values. You have different breakpoints, like I said. There's so many different ways to make codes. I just don't want you guys to get stuck in this copy-paste mentality where you're doing the same thing over and over again with no creativity, no intuition, no innovation. So remember that every situation in your coding journey will be slightly different. I mean, it's okay to do some methods a little bit over and over again for certain scenarios, but just don't get stuck doing the same thing nonstop over and over again like a hamster on a wheel. Okay. This is just what I represent is just a very, very basic way of manipulating dynamic memory to find some byte values to make a code. Very simple. Let's go back to the thread and see if I missed anything. And sorry if I had to go through that a little fast while we're making the code. Once again, we're limited on time in a race. Covered that, covered that. And one thing I forgot to mention is you can decompile a code. So let's say this was blank. This was blank. Now if you have your X placeholder here, you need to put some value in, so let's put value 1 for first place. Click the left arrow instead of the right arrow, and we get it. The one thing I hate about ASM compilers, when you use decompilers, it doesn't matter. When you decompile codes, it doesn't matter if you use the Python one or WeRDGUI. They put all these values, anything that's a value, they put them all in decimal. Extremely frustrating. I hate it. And they don't have spaces right here, but that's no big deal. The decimal thing is huge, and they always put the NOP, which is no big deal. But the decimal thing, that really, that sucks, in my opinion. Okay, so that's how you decompile codes. Obviously, if you can't get WeRDGUI to work, small tutorial how to get the Python compiler to work, which is what I personally use. And chapter 9 on here, testing/porting your codes. If you don't care about porting, I can understand not wanting to do it because you spend all this time making the code, and now you gotta go through the annoying task of porting it, which can be a nuisance. This code is actually easy to port, by the way, if you want to go ahead and do it, but we already have it posted on the forum. All regions been tested a long time ago. When you're testing your codes, as I said in episode 6, it's recommended you have an original Wii console. Wii U console's alright, but preferably it's a Wii console, plain Jane Wii console. So you can test your codes on both the Wii, on a real Broadway CPU, and on Dolphin. But if you don't, just try the best of your abilities. Always test your codes thoroughly. Even though this code is for online use, you can try to go ahead and test it for offline or some other mode. Don't be surprised if you get a crash or a freeze by doing that. But yeah, always thoroughly test your codes. And I think that's pretty much it, guys. In the next episode, episode 9, we will talk about ASM and register safety. Now, this link right here, the simple ASM reference page I talked about in the previous episode. Once you learn ASM and some instructions, if you don't know if a certain instruction exists or you need help using certain instructions like multiplication, division, byte storage, or anything else, this is a list of just a bunch of instructions with clear examples, easy to read, easy to use, and whatnot. Okay, guys, and that is it. I appreciate anyone who watches these videos. All right, till next time, signing out.